Problem 5 mentions how in 1968 the U.S. minimum wage is $1.60 per hour, and in 1976 it was $2.30 per hour. Then it asks us to create an exponential model using W of t, where t is time in years after 1960. So first, formula of WT, first we need to understand that the base formula is going to be W of t is equal to the initial W, W being wage, times e to the k times t, and we use the information we're given to find that. So first, let's focus. Come on. We have W of 8 is going to be 160 equals W0 times e to the 8k. We just plug the numbers from up here into this formula here to get that. And same for W16. And then the problem is that with the information here, we have two variables we need to solve for. We have W0 and k. But so whenever you have two variables you need to solve for, and this is the only information given, you basically need to figure out how to eliminate one of the things your variables. And well, not in this case. In this case, one thing we're eliminating is constant W0. And the way we can do that is by dividing one by the other. And what will basically happen is, or the reason why we can do this is because these two are related to each other. They're on an exponential function. We know that's what we're trying to find. And when we divide it, we can cancel out the W0. And what we're left with is 23 over 16, which is just moving the decimal over and dividing, equals e to the 8k. And then to cancel out this e and bring the 8k down into something we can solve, we just add natural log to both sides. So you have natural log of 23 over 16, you punch that into a calculator, you get 0.3629. Natural log of e is natural log base e times e, which just cancels out to 1, so you can just cross that out or make it disappear, whatever, and you get 8k in its place. Just divide by 8 both sides of your calculator, and you get 0.045363. Now that you have k, you can plug k into either W of 8 or W of 16, and solve for W of 0. What you end up getting is 111. And then you plug W of 0 and k into our initial formula, and what we get is W of t is equal to 111 times e to the 0.045363 t. So then the next part of the question asks us to find what minimum wage is predicted to be in 1960. So that would be when t equals 0, but of course, anytime you multiply 0 times anything, you get 0, and then anything to the 0th power is just 1, so this entire side cancels out, and we know that when t equals 0 in 1968, the minimum wage is predicted to have been $1.11. And then it asks us to do the same thing in 1996, so we just have to figure out what t is. We do 1996 minus 1960, and we get 36, so that's what t is. Plug in for W of 36, punch it in your calculator, and you get $5.68. And it asks us, was it above or below the actual minimum wage? So it was predicted to be $5.68. The actual was $5.15 according to the problem. So we missed the mark there. All right, thanks. Don't forget to like and subscribe.